Hi. In this episode, we are going to look at the operations, binary operations. But before that, let's have a recap of a special property that we already looked at in chapter 1, talking about the types of set or numbers that we have. So we spoke about natural numbers, whole numbers, integers, rational numbers, and all that. Now in chapter 2, we have a definite property that we can call it, which is closure property. Now, if an operation is performed on elements of a given set and the result belongs to the given set, then we say that the set is closed under the operation. Now, note the following. I, the set of natural numbers n, whole numbers w, integers z, rational numbers q, and real numbers r are closed under addition. They are closed under addition, right? Since, for example, when two integers are added, we obtain another integer. Now, so you may have asked yourself, if you're going to look at binary operations, why look at this? But this will give us an insight, like it will set the pace for us. So more like a pace setters, right? So that is it. I'm not going to say much here because we have already looked at in chapter 1. If you care to know more on this platform, check. You will see that. Now, in II, only the sets of integers z and rational numbers q and real numbers r are closed under subtraction. Since, for example, when we subtract any two rational numbers, we obtain a rational number. However, the set of natural numbers n and whole numbers w are not closed under subtraction. Right, so I know you remember all these letters, the numbers, the types of numbers or sets. That is it. We looked at this in chapter 1. Now let's continue. In III, we are saying that no set can be closed under division, right? If 0 is a member of the set, right? Now the set of natural numbers n, whole numbers w, integers z, and rational numbers q are therefore not closed under division. Note that we say the set of integers is not closed under division because not all integers when divided gives an integer. For example, 1 over 2/3 is not an integer. So when we exclude 0, the set of rational numbers q is closed under division. Right, now let's look at the last property or statement or expression. We are saying that if the operation plus or addition is defined over the set S, which we have 1, 2, 3, 4, then 2 plus 3 is equal to 5, which does not belong to the set. So this 5 is not found here. That's the set that we are talking about. So after doing your calculation, the resultant force, why am I saying resultant force? Are we doing physics? The resultant figure or value should be here. If not, it is not. So that's what we are talking about. Now let's move to our main topic of the day. Now, so binary operations, right? So binary means we are dealing with what? Two operands. If you care to understand the operands, what the operands and operators are, watch the recent video. Yes, so here we are talking about the basic operators or operations in addition in math. We call it arithmetic operation or all that. Now, the four simple operations in mathematics, right, are addition, subtraction, multiplication, and division, right? These operations may be defined on the set of real numbers. In this chapter, we are talking about real number system. That is it. Now, they are called binary operations because they combine two numbers to give another number. For example, 2 plus 3 is equal to 5, or 2 times 3 times 5 rather is equal to 10. However, if the operation is not one of the simple operations, right, then the operation will be defined for you. Any two numbers can therefore be combined by strictly following the definition of the operation. So if the operation does not fall under any of these four simple operations, we define it by giving you an operation and then defining or expressing what it means or how to do a particular question or solve a calculation. So that is what it means by they'll give you a strict instruction to follow. Now, in most examples, the binary operation would be defined as in the following examples. Follow the definition of the operation to perform the calculation. So, example, here we have example 1, the operation star. Let me put it, the operation star is defined as, so m star n is equal to m plus n plus mn, right? So it means that whenever you see an expression of this sort, so m and n are just variables. They are letters standing for numbers, right? So you can be given a question with the number, and then when you see in this form, in this particular expression, it means that it's m plus n plus mn. So m could be 2, n could be 3. So if it is 2 and it's 3 here, then 2, 3 plus 2 times 3. That's what it means. So now, given that expression, you have been given this to evaluate. So I is 3 star 4. And then we have II 4 star 3. So that is what it means. So evaluate this. So you take I, then you do II, then you continue in that sense. That is what it means. It's very, very simple. But if you don't do the substitution correctly, you will find yourself wanting. That is what it means. So let's start with the solution here. It's simple. It's one of the simplest or easiest topic to be treated under math. So this is more like watch and learn, or watch and do. So you watch as we do, watch and do, watch and do. So that's what it means. Now that we have the expression, now put the expression down again. M star n is equal to m plus n plus mn. This is the definition of the word operation star. So with the I 3 star 4. Now looking at this, you do substitutions. It's as simple as that. So you can watch this or pause the video. Maybe what I'm saying is faster because maybe I think it's easy, but that's not it. I'm very relaxed with this. So pause the video and watch this very carefully. So it's just a matter of substitution or substituting. So 3 was here, 3 star 4. So it comes in that way. And you do the substitution rightly, correctly. Don't interchange, or when you have to put a 3 at a point, you interchange. Don't do that. Put it as it is in the expression given. So if you understand this, then I wouldn't worry myself doing the rest of the examples. That's why I'm taking my time to do this. So 3 star 4, you have 3, 4 plus now 3, because this is 3. Now the 4 comes. Right. So what do you get? We have 7, and then we have 12. You add 19. Then you bring the II again. The II is now 4 star 3. You do the same thing, you get 19. So 19. Now the B aspect is what are we required to do? We should compare the answers in AI and AII, right? So we are supposed to demonstrate a property. So that's what it means. So here we can see that from I and II, star 3 star 4 is equal to 4 star 3. So we learned the property of a commutative that when numbers or variables are interchanged, they will still give us the same solution, the same answer. And that's exact thing that we have seen. So with star 3 star 4, we got 19, and then 4 star 3, we got 19. So this property is commutative. So it's as simple as that, right? So with that understanding, the rest is simple. Even the other examples that I may not do, it's just a matter of watching, doing substitution, and then doing it. So I think that will bring us to the end of chapter 3. The next video will be on this chapter 2 rather. The next one will be chapter 3, where we do algebraic expressions. So we will see you now in the later video. Please watch, like, share. Let's just hit 1K following, and we can start doing live.